Good afternoon, everyone. In this video lecture series, I'm going to explain about phase shift keying. Phase shift keying is nothing but it is a digital modulation technique in which the phase of the carrier signal is based on the inputs at a particular time. Where PSK technique is widely used for wireless LANs, biometric, backplanes operations, along with radio frequency identification and the Bluetooth communications. The BSK is of two types depending upon the phases the signal gets shifted. They are the binary phase shift keying, that is it is also called as a two-phase PSK or a phase reversal keying. In this technique, the sine wave carrier takes two phase reversals such as a 0 degree and a 180 degree, where Bpsk is basically a double sideband suppressed carrier modulation. So the message being the digital information. In QPSK, this is the phase shift keying technique in which the sine wave carrier takes four phase reversals such as 0 degree, 90 degree, 180 degree, and the 270 degree. The Bpsk modulator will be having here the bipolar NRZ level encoder and a balanced modulator. Then from the balanced modulator we'll be getting a BPSK signal and a carrier signal. The baseband signal is applied to the modulating signal to the balanced modulator. Then this NRZ level encoder converts the binary data sequence into the bipolar NRZ signal, and this signal is being fed to the balanced modulator as the carrier wave signal, and the binary sequence. mm, yes, the acknowledged binary sequence is being given as one of the input, and the carrier wave generator, that is carrier signal, is being given as the second input to the balanced modulator. Whereas in the modulation of this BPSK is done using a balanced modulator which multiplies the two signals applied at the input. For a zero binary input, the phase will be 0 degree, and for a high input, the phase reversal is of 180 degree. The output sine wave of the modulator will be the direct input carrier or the inverted input carrier, which is a function of the data signal. Next one is a BPSK demodulator. In this, first we receive the signal and it is being given to the squaring circuit, and then from the squaring circuit it is being given to the band pass filter, and from the band pass filter it is being given to the frequency multiplier, and from the frequency multiplier it is being given to the synchronous detector. Then from the synchronous detector it is being given to the integrator, and from in between the synchronous detector and the integrator we will be having the bit synchronizer. There are various types of operations in the receiver. The first one is a phase shift in the received signal. The second one is the squaring circuit. The third one is the band pass filter. The fourth one is the frequency divider. The fifth one is synchronous demodulator, and finally the bit synchronizer and the integrator. In the phase shift signal, the signal undergoes the phase changes which depends upon the time delay from the transmitter to the receiver. This phase change is uh, normally fixed phase shift in the transmitted signal. So let the phase shift be theta. Therefore, the signal at the input of the receiver is S of t, which is equal to d of t root of 2p cos 2 pi f naught plus f naught t plus theta. Then the next one is the squaring circuit. Now from this received signal, a carrier signal is separated since it is a coherent detection. So it will be neglected because we are only interested in the carrier signal. So band pass filter. This signal is passed through the band pass filter whose pass band is centered around 2f naught. Then this band pass filter removes the DC level of 1 by 2, and its output we get as a cos 2 of by f naught plus t. Frequency divider, where it divides the frequency divider and will get a carrier signal whose frequency is f naught. And then synchronous detector. This synchronous demodulator mainly multiplies the input signal and the required signal. Therefore, at the output of the multiplier, we get the multiplier signal. Then finally, bit synchronizer and the integrator. The above signal is then applied to the bit synchronizer and integrator, where the integrator integrates the signal over one bit period. The bit synchronizer takes care of the starting and the ending time of the bit. So, at last, the bit clock rate is needed at the detector circuit to produce the original binary message signal. Thank you.